In this example, we're going to graph the exponential function f of x equal to 3 times 4 to the x. So notice in this case our constant out front is 3 and we have a base of 4. Our variable x is in the exponent. Before we graph this function, I want to take a second to talk about exponential functions in general. So we could write an exponential function in general as a sub 0 times a to the x, where a sub 0 is our constant out front and a is our base. Now our base a is a positive value, it's greater than 0, and it's not equal to 1, because if our base was 1, we would have 1 to the x, which would end up giving us just a function that is constant. Now when talking about our base a, let's break this up into two cases. Let's look at what happens when our base a is greater than 1, and then let's also look at what happens when our base a is between 0 and 1. When our base a is greater than 1, we can expect the shape of our exponential function to have this general shape here. So what we have here is a positive increasing continuous function, and as x gets smaller, our function approaches 0. The graph is concave up, and the x-axis is a horizontal asymptote. We have a y-intercept, and that y-intercept point is given by 0, a sub 0. So whatever that constant out front of our function is, that'll tell us what our y-intercept is. Because if we think about what happens when we plug 0 in for x, a to the 0 power is 1. So our function value becomes a sub 0. Now let's think about what happens when our base a is between 0 and 1. So we can think of a as a positive fraction that's less than 1. Then our function then has this general shape. So now what we have here is a positive decreasing continuous function. And as x gets larger, our function approaches 0. The graph is concave up, and once again our x-axis is a horizontal asymptote. Again, we can plot our y-intercept there. It's given by the point 0, a sub 0. So when we go to graph an exponential function, we can expect our graph to look like one of these graphs here if our exponential function is of this form here. So now let's graph the exponential function f of x equal to 3 times 4 to the x. Now we have a general idea of what our graph should look like, but to help us out here, let's pick some x values and get the corresponding function values. For example, I could choose x equal to a negative 1, let's say. I'll choose 0 to get our y-intercept, and we'll try 1. When I plug negative 1 in for x, 4 to the negative 1 is a 1/4 times 3, gives us a function value of 3/4. If we plug 0 in for x, that gives us our y-intercept, which in this case is going to be 3, that constant out front. And then plugging 1 in for x, 4 to the first power is 4. 4 times 3 gives us 12. Now let's plot these points on our xy axis. A negative 1 3/4, a 0, 3. And then since 1, 12 would put us off of this xy axis grid I have here, I'm just going to leave that one off. We do expect our function to grow exponentially as x gets larger. So now let's connect these points here. And there's that shape that we were expecting for our graph. We can label our points here. So our y-intercept is the point 0, 3, and I'll label that additional point there the negative 1, 3/4. Alright, so there's our graph of our exponential function.